A lot of my students find it difficult to prove that the inverse of this Tanhx function can equal a half ln of this function here. So I've made a 4-step method that hopefully helps simplify this as much as possible, and let's have a go at applying it. So to start with, the function that we're replacing, the inverse Tanhx of x, let's introduce that as a function y. After we do that, we can apply step number 1, which is apply Tanhx to both sides of the expression. You might call Tanhx something else, by the way, but that's completely fine. Now, when you apply it to the right-hand side, it cancels out with the inverse Tanhx, leaving you with just x. Now, step number 2 tells us to multiply by e to the y over e to the y after using this function here. So let's use this function. We can replace Tanhx of y, the left-hand side, with e to the y minus e to the minus y, all over e to the y plus e to the minus y. Now, after making that equal to x, the right-hand side, we're going to multiply by e to the y over e to the y. But we actually don't do that to both sides of the expression. We only do that to the exponential side of the expression. So I'm going to do this in a different color just to make sure that that's as clear as possible to you guys. And the reason we're allowed to do that to only the left-hand side and not the right-hand side is because, well, e to the y over e to the y is just 1. It ends up cancelling out, so it does just equal the same thing. So we're allowed to do that. And we do that because it helps us actually get to the answer. So e to the y times e to the y is e to the y plus y, because we're multiplying indices, so that's e to the 2y. E to the y times e to the minus y is e to the 0, which is just 1, because anything to the power of 0 is 1. Similarly, the denominator will be e to the power of 2y, this time plus 1, is all equal to x. We've done step number 2 now, and now we're going to multiply both sides by the denominator. So the reason we do that, again, is to clean things up and to make it in a format where it's easy to differentiate, but to formulate when we need to. So when you multiply the left-hand side by that denominator, you're going to be just left with the numerator. And the right-hand side, well, x times e to the 2y is x e to the 2y. And then x times 1 is just plus x. After we've done step number 3, we're going to separate the exponential term, meaning all the exponential terms, we're going to take them to one side, and we're going to take all the terms that don't have exponential to the other side. So we're going to take away x e to the 2y from both sides, so we get e to the 2y minus 1 minus x e to the 2y all equals x. And if you're thinking a step ahead, you'd also add 1 to both sides, because that would leave only the exponentials on the left hand side. After you've done that, you can factor out the exponentials of e to the 2y, because to go from e to the 2y to that same term, you multiply 1. To go from e to the 2y to minus x e to the 2y, you multiply by minus x equals x plus 1. And let's write this out as 1 plus x. It's going to look cleaner after we divide both sides by 1 minus x, because then we get e to the 2y is equal to 1 plus x all over 1 minus x. Now that we've separated the exponential term, we're now going to apply ln to both sides of the expression. One thing I do want to note to you is not applicable here, but if you have 2e to the 2y, you wouldn't be able to apply the ln function yet. You'd have to divide both sides by 2 so that there is no number before this exponential term. Now when you apply ln to the right and left hand side, well, ln e to the 2y is the same thing as 2y ln e, so it will be equal to just 2y. And that will equal ln of everything that's already on the right hand side, so that's 1 plus x all over 1 minus x. After you've done that, you now divide both sides by 2, and then voila, you end up at y equals a half ln of 1 plus x over 1 minus x, which is exactly what it's wanting you to show here. So pretty difficult method, and I've written down 4 steps, so you guys do have condensed notes of what to do with this question. So yeah, be sure to leave a like if the video did help, and subscribe. I'd appreciate a lot. Thanks for watching. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-Level Further Maths, be sure to hit my website up at www.excelineducation.co.uk.